In the previous video, we were able to derive the domain and range of the function defined by y is equal to tangent of x. And we discovered that the domain of this function is the set of real numbers except pi over 2, okay, 3 pi over 2, 5 pi over 2, so on and so forth. These are the odd multiples of pi over 2. So that is the meaning of this notation. The domain of y is equal to tangent of x is the set of real numbers except this. What is the range? This is the range. It's the set of real numbers. Now let us go back to the domain. Why did the domain of our function came to be this way? Well, we have to go back to our unit circle. So how do we compute? How do we compute for the tangent of an angle? So what we do is we trace an arc in our unit circle and we pay attention to the terminal point of that arc. So when it is pi over 2, the coordinates of the terminal point of that arc is 0, 1. And what is tangent? What is tangent of pi over 2? It's 1 over 0. And this is undefined. The same thing happens when our angle is 3 pi over 2. The terminal point of our arc is 0, negative 1. So what is tangent of 3 pi over 2? It's equal to negative 1 over 0. And this one again is undefined. So something like that happens whenever our arc would have a terminal point that lies in the vertical axis. And those arcs would be arcs whose lengths are this: pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. Nothing about the sine and cosine functions and their graph will prepare you for how the graph of the tangent function looks like. So this is a smaller picture, a zoom-in picture of that graph, and this is the larger picture of the graph of the tangent function. You know, I can remember my days when I first sat in a class and our teacher was talking about the graph of circular functions. One day we were talking about the graphs of sine and cosine, and the next day it was tangent. And nothing from the graph of sine and cosine prepared me to accept this, to even imagine that this is how the graph of our tangent function is going to be. Okay, so what do we have here? So we have these invisible lines. These are our vertical asymptotes. These vertical lines are not part of the graph, but they are there and they are defining the shape and the direction of the graph of our tangent function. Where did these lines come from? It came from this, okay? We remove this from the set of real numbers, and we call each of those lines your vertical asymptotes. You know what happens with the graph and the vertical asymptotes. You know how the graph behaves in relation to the vertical asymptotes. The range of our function y is equal to tangent of x is the set of real numbers. Let us pay attention only to the graph in the interval 0 to 2 pi. So that corresponds to 1 revolution in our unit circle. When our angle is 0, okay, so we will pay attention to this. Tangent of 0 is 0 divided by 1. That's 0. That's it. Now, in the first quadrant, when your angle is an angle whose terminal point would be in the first quadrant, this is quadrant 1. So this is going to have coordinates. Okay, so I will call the coordinates W and Z. Okay, I will call the coordinates W and Z. So tangent of x, okay, this is now x. Tangent of x is equal to Z over W. But in the first quadrant, z is positive. The second coordinate of your point is positive. And the first coordinate of your point is also positive. And so this thing, z divided by w, the second coordinate divided by the first coordinate, is going to be positive. That is why our curve in the first quadrant, 0 to pi over 2, is above the horizontal axis. So what happens now when our arc is in the second quadrant? In the second quadrant, okay, so you will have coordinates there. Let us call it w and z. Z is still positive, but the first coordinate is negative. And so when you compute for tangent of x is the length of our angle now. It's going to be z over w. They have different signs. They have differing signs. One is positive, one is negative. So this is negative. That is the reason why in the interval pi over 2 pi, our curve is below the x-axis. Now again, what is tangent of pi? Tangent of pi is 0. Okay, again, that is our reference point. So what happens now when we get to the third quadrant? So in the third quadrant, let us say that is the terminal point of our arc. The z-coordinate, the second coordinate, is negative. The first coordinate is also negative. And so when we compute for tangent of x, it's going to be z over w. Both of them are negative, so this is positive. And so that explains why our graph is above the horizontal axis in the interval pi to 3 pi over 2. It's above the horizontal axis. Now, when our arc is in the fourth quadrant, the coordinates of our terminal point would have different signs. They have differing signs. And so when we compute for tangent of x, it's going to be negative. That is the reason why our curve is below the horizontal axis in the interval 3 pi to 2 pi. Let us pay attention to the behavior of your curve as they approach the vertical asymptote. When our angle approaches pi over 2, the terminal point of that angle approaches this, 0, 1. Z approaches 1, but W, the first coordinate, approaches 0. When we compute for tangent of x, the numerator approaches 1 and the denominator approaches 0. What happens when you divide 1 by something that is approaching 0? Well, the resulting value of your tangent function approaches infinity or positive infinity because you are in the first quadrant. Now, in the second quadrant, close to pi over 2, the value of your tangent function is negative. And so that is why, look at this. The curve approaches negative infinity. From pi to 3 pi over 2, as our curve approaches 3 pi over 2, again, something like 1 divided by something that is approaching 0, and the result of that is this one, it's positive infinity. When you get to the fourth quadrant, it's going to be negative infinity because in the fourth quadrant, your tangent function is negative. This is the graph of y is equal to tangent of x. And why don't you do it again? Okay? Close your books, close your notebooks, finish this video, and in a piece of paper, try to sketch the graph of the tangent function one more time.